Hi everyone, I'm Joe McGregor. I'm one of the co-leads of the Glaciers and Sea Level Community of Practice, along with Caitlin Harbeck and Zoe Corville, who are here. And thank you all so much for joining. Today, we're going to be talking about community engagement in glaciology. Before we proceed further, if you're new to IARPC, Glaciers and Sea Level Community of Practice meetings, sorry, I called it collaboration team, that's the outdated term. If you're new to our meetings, just go ahead and briefly introduce yourself in the chat here. Thank you again for joining and looking forward to this discussion today. So we're going to hear from two speakers on the topic of how folks are handling changing sea level rise that is coming not just from Arctic ice, but also from glaciers in temperate regions, warming growing volume of the ocean and the Antarctic as well, how that's being addressed on a community level, both people who try to estimate how much sea level rise is occurring and then how that affects communities, and then how those communities themselves are responding to that as well. So we're very lucky. We've got two speakers lined up today to discuss that topic. The first is Assistant Professor Alex Robel from Georgia Tech, I think the School of Earth, Atmospheric and Ocean Sciences. I might have that a little out of order, who has been studying this topic for a while and is also a Miami native, and so has particular interest in one of the regions that the United States is most vulnerable to in terms of sea level change. And so how he's engaging with communities both in Georgia and potentially elsewhere. And second, we'll get into even finer detail on how this is affecting the southeastern United States. We'll hear from Nadia Seeteram, who is a postdoctoral research associate at the Columbia Climate School, and who has carefully studied how changes in sea level will affect populations at a pretty fine scale, much finer than I had previously considered in Miami-Dade County, and maybe talk about how that the framework that she's developed might be applied elsewhere. So we'll have these two presentations. If you at any point have a need for clarification, feel free to raise your hand using the Zoom system, and perhaps we can, if the speaker can see it, we can easily address that. Otherwise, in between the two presentations, we'll have time for brief points of clarification. And then the hope is to open up a broader discussion after that. So that's the plan. And I think we'll, absent any questions, we will go ahead and get started. So first up is Alex. And Alex, would you like to take the lead and potentially share your screen?
Great, thanks, Joe. Can you all see my screen? Yes, and hear me okay? Great.
Yep.
Let me minimize all these things. Well, first off, I just like to thank IARPC and this community of practice for inviting me to give this talk. I will admit, I need to admit off the bat that I think I'm still relatively new to this space, even though I sort of, grew up in a region that is being severely affected by sea level rise. As a scientist and thinking about how to engage with practitioners and how to engage with coastal communities who are already dealing with the effects of sea level rise, I've come to that really just in the last few years, and particularly through some projects that have been spinning up at Georgia Tech since I started here in 2018. So, I will give that preface and also, point out that I see other people here on the call who have also worked in this space, and I think if there are things that I miss or that I get wrong in the process of perhaps trying to recommend or talk about how, as a glaciologist, I've tried to engage more with coastal communities, please, after the talk, feel free to jump in and ask questions or correct or add to, anything that I've said. And so part of that, so there's actually a video here. That's great. Starting is I actually realized that, in sort of preparing the title of this talk, I was perhaps a bit more cavalier with the title. So I've sort of modified it here. Really, the goal of this talk is to speak from personal experience about what I think ice sheet scientists can do to work with coastal communities, and that's really sort of the theme of this talk. That I want to really get to at the beginning here, or start from the beginning, talking about this. And if anything, if you take away anything from this talk, it should be this working with rather than for. This ultimately gets at how we as ice sheet scientists or as glaciologists think about the work that we do and how it is utilized by coastal communities in order to make decisions. And so the context that I'm starting with here is this drone video. Ooh, let me just run it again real quick. That's running in the background of my slide. So this is from 2015. This is at the Georgia coast. This is a shot over Highway 80, which connects the mainland of Georgia, where Savannah is located. So it kind of starts at the outskirts of Savannah, and then it connects to Tybee Island, which is a barrier island community about a 15-minute drive from Savannah, that has a sort of total year-round population of like 5,000 to 10,000 people, but also a very large tourist destination here in the Southeast. What I want to point out with this video, and this is a video I show a lot at the beginning of my talks, is that so this is not a hurricane, this is not a storm event or anything like that. This is a day in 2015 when a kind of just slightly above average onshore breeze coincided with a king tide, which is sort of the annual highest high tide. And what that caused was the lowest lying parts of this Highway 80 to flood over, and ultimately Highway 80 was shut down as a result of that. And this is not, especially at this time in 2015, was not an abnormal occurrence. Highway 80 was built in the 1930s, and it was built at an elevation that made sense for the sea level of that time. But now that sea level is higher in this region, and I'll show the context for this in about 2 slides, this recurring flooding has become a problem. And in particular, it's a problem, this will get me to my next slide, which is that Highway 80 is the only road connecting Tybee Island to Savannah. So Tybee Island is a small enough community that when this road is closed down, the residents of Tybee don't have access to a lot of emergency services. There's no hospital in Tybee, so any medical emergencies require sort of a helicopter airlift when Highway 80 is closed. So this is a major problem when this road gets flooded and when it gets closed down. And the context for this, I'll just point to, so the red line here is Highway 80, and then the blue dot is the location of the Fort Pulaski tide gauge, which is the, until a few years ago, was the only tide gauge or sea level measurement instrument in the state of Georgia. And it was built in the, it was first started recording in the 1930s. And you can go nicely on the NOAA website, and this is like an exercise that I have my students do in our sea level class that we teach here, to kind of do this exercise. So I'll just show you, if you do a quick histogram of the highest or of the high tides occurrences. So this is histograms with the high tide level on the x-axis and the frequency of occurrences per year of that high tide level over a 5-year period. So the blue line is from the period 1935 to 1940, right after the tide gauge was erected. This was also just a few years after Highway 80 was built. And then the red line is over the period of 2014 to 2019. So you can see one sort of very nicely, just the translation of the histogram to the right to higher baseline sea levels. That's about a foot. And the gray dashed line here marks where the lowest parts of Highway 80 will flood for different high tide levels. So you can kind of see basically why it was a good idea to build Highway 80 to the elevation it was in the 1930s, and then why it became a problem after a foot of sea level rise starting in the 21st century. And so the result of this was that starting in 2019, the Georgia Department of Transportation spent the first of several $1 million, and what will certainly not be the last, to raise just the very lowest parts of Highway 80 by 8 inches. And so what that 8 inches got you is to this black dashed line, which is where the sort of lowest elevation parts of Highway 80 are now. And as you can see, this has sort of mitigated the existing problem of flooding on Highway 80 to a certain extent, although it does still flood once or twice a year, and certainly when there are storms or things like that. But this is, of course, not solving the long-term problem of sea level rise for these communities. And really, the central problem here is that most communities use little or no information from state-of-the-art ice sheet and sea level projections. So this is a really wonderful paper it was a preprint for a while, but now it just was published this year by Daniela Hirschfeld, who is a planning professor at Utah State. And basically what this shows is in North America, it shows what fraction, so the bar at the top shows what fraction of survey respondents, and so this was a survey that was done of practitioners who do planning or engineering in coastal areas throughout North America. And what this bar graph shows is the percentage that use, and so this is of the participants who say that they're using sea level projections in some way to do their planning, what fraction of them use one number, so that's A, or in the orange here, 2 numbers or 2 projections in the green, 3 in the gray, and 4 or more in the blue. And so what you can see here is that the vast majority of planning professionals who do use sea level projections in planning use either a single number or use maybe 1 or 2 numbers. And if you also see very helpfully here on the right, this is the sort of similar range from the recent AR5 and SROC reports showing, I would say, like our current community consensus for global mean sea level projections for the year 2100. And you can see that these projections or these numbers that are used by practitioners are largely not the same. In fact, if anything, they're higher than our community consensus. And so, the reason why I show this to start is that it really gets across the fact that beyond the science problem of uncertainty in sea level projections, there's a real communication problem in sea level projections, because there is this sort of disunion between the numbers that are being actually used by communities to plan for future sea level rise and the numbers that we are providing. So, the first takeaway here, and I'll come back to this, is that as a community, we need to be making much more effort to build those relationships with communities and with practitioners who use sea level information, and to do a better job of communicating that information. And even when we are producing projections that we intend to be used, we need to do a better job of communicating and disseminating that information in the papers and thinking about the outlets that we use to disseminate that information. So that's sort of part one. And then the rest of this talk is really about, practical ways that ice sheet scientists can help to facilitate effective adaptation by coastal communities with the best possible information. So this is just going to be a list, kind of going through a few slides and then showing some examples along the way. And I realize I've kind of spent a lot of time already kind of spinning up the problem. So Joe, because I don't see anyone on my screen, if you want to jump in when I've spent too much time, I can jump to the end. But so part one, and this is really, I do this as recommendation one, is that, this is meant if you are a glaciologist or an ice sheet scientist of some sort, and you've never worked with coastal communities before, step one, and really the most important thing that you can do, is to start to build relationships. And there are, I would say, two kinds of groups that you can build relationships with, and they're not mutually exclusive. One is what are called boundary organizations. And so these are organizations that exist, particularly in the US, whose main purpose is to serve as an intermediary between scientists and particular academia and communities who need the information that are being produced by scientists. So they partly play a role of helping to build those relationships, but also translating, things in scientific language to information that is more easily used by the public at large. So examples of this, the sort of best example of this is that NOAA has these climate adaptation partnerships. These were formerly called RISAs, but now they're called CAPs or CAP RISAs. And so these are regional organizations whose sole purpose is really to help intermediate these relationships between communities who use climate information and are trying to plan using information about climate and the scientists who are producing that. And then a local example here is the University of Georgia Extension, although many land grant and other state universities have these extension programs that also do a lot of this work. And so getting into contact with, if you have a regional CAP, we don't yet have one here in the Southeast, but if your university has an extension office, or your state university that you might be affiliated with has an extension office, this is a really great way to start to build those relationships with communities and practitioners. So that's part one. And this is a really, number one is a better way to facilitate what we would call co-production, right? That is, yes, translating your science after it's done, but also designing science and designing the way that you do science from the beginning, along with the communities who you want to use that science, to make sure that the science that you're producing is useful and usable to the widest possible range of people. But the second part that I really want to kind of emphasize here is that part of the reason why co-production is necessary to begin with is because largely we see that as scientists, we are a distinct group of people from those who we are trying to serve or trying to produce information for. And this really, it kind of emphasizes the fundamental problem that our community does not look like and largely does not draw from the communities who we are trying to serve. And so my second recommendation is to be recruiting students from frontline communities into ice sheet science, so that those with the lived experience of like what sea level rise means for coastal communities who, have lived through flooding events, have lived through hurricane storm surge events, right? They can become scientists in this field, and they already have the experience and perhaps the personal relationships within those communities to build those relationships. And so there's a number of ways, that can be done through REU programs. There are great organizations that have been spun up in the last 5 or 10 years, like Polar Impact and IGS, the Early Career Glaciologist Group. And then there's other existing programs like LSAMP that are designed to help do a better job of recruiting students into science graduate programs. So that's my second recommendation. My third one is really to be, rather than telling, to be listening to communities and practitioners tell us what they need. So once you develop those connections to boundary organizations or communities or practitioners, or let's say community groups, going in there and telling them what you do, and then seeing, oh, well, how can what I already do be useful to you? That is really not a useful way or not a good starting point for building a relationship. And so going into those meetings, to those introductory meetings, to those conversations, and starting by shutting up, listening to what other people are telling you, or what communities and practitioners are telling you that they need, what information are they lacking to make informed, good decisions about planning, about infrastructure, et cetera. And then design your science on the basis of that. And so just an example from here in Georgia, we have a program called the Smart Sea Level Sensors program that was really designed based on input from the community in Savannah, Georgia. It is a low-cost, it's effectively a low-cost tide gauge. So whereas a sort of conventional tide gauge would cost about $10,000 to build and install, these sea level sensors are built using off-the-shelf components, and they each cost about $300. And so as a result of that, like I was saying before, we have had one tide gauge in Georgia for about the last century. So that was the situation about 5 years ago. And then this sensor was designed. This was by other folks at Georgia Tech in collaboration with community groups in Savannah. They designed this low-cost sensor, and we now have the densest network of sea level observations in the world in Savannah and actually and now down the Georgia coastline. So there's about 60 of these sea level sensors in different kinds of communities, areas with different risks of flooding, different sort of hydrological characteristics, around this region. And these give us real-time observations. Here's a screenshot from the website where you can click on one of these dots. Each of those is a sensor, and it'll pull up real-time information on water level from those sensors. This program has now morphed into this SEER hub. This is a coastal equity and resilience hub that was funded through a line item in the last federal budget, actually. And so this SEER hub is now just spinning up and really trying to expand the scope of what this SSLS program started with. And I'll talk about that in a second. All right. So when we do tell communities what we do know, we need to be clear about telling communities what we know, but also what we don't know, right? And this is sort of getting back to that first slide about uncertainty in sea level projections and how that's being interpreted by the people who are using those sea level projections, is that we need to be very, very clear about what are things that we're confident about. So for example, sea level rise at 20 to 30 year timescale, that is something that we are confident about. I can't see Jeremy's face here, but I hope he's happy and nodding at that. But then things that we don't know about, variability in local sea level, about sea level at very high resolution, uncertainty in global mean sea level at longer timescales, right? Being clear about those things, because those then set up also the conversation that I think we've been having internally within our field, which is that talking about all the things that we need in order to do a better job in terms of funding, in terms of research infrastructure and support. It's harder to have those conversations if you haven't already laid the groundwork by talking about the successes that we've had as a field in kind of, doing projections at short time scales, but also, what the problem is and why those are problems for coastal communities, because then you're not just advocating for yourself and research funding for yourself, but you're also advocating for doing a better job at getting information for coastal communities, and then you can enlist coastal communities as advocates for this kind of work. So that's another part. And here I've put some figures from Ginny Catania's paper, or led by Ginny Catania in EOS last year, kind of showing this oft remarked about disjunction between the amount of research that's being done in glaciology and the funding that is being given towards cryosphere research in the US, at least. Okay, I'm going to skip through some of these things because these are a bit more specific, but I'd like to get to the last 2 points. So another point that I want to get across here is that the information that communities want and need is not always global sea level projections. And this is very hard, I think, often for us to hear as glaciologists, because most of us start our proposals and our papers, and I'm certainly guilty of this myself, by saying like, well, the reason why we do all this is because we're improving sea level projections. And obviously, global mean sea level projections are the most important thing that everyone needs to deal with coastal resilience and coastal flooding. But the reality is that coastal flooding is a very complicated problem that involves lots of different, disciplines and other problems. So an example here is the fact that at the local level, the local sea level rise that is experienced by communities is the sum both of the change in the sea surface height due to things like glacier melt, but also due to vertical land motion. And in many places, particularly in the United States, and particularly in the southeastern United States, the amount of locally, or what we would call relative sea level rise that is due to vertical land motion is much greater than the amount of sea level rise, the relative sea level rise that is due to glacier melt or thermal expansion of the oceans, et cetera. And so what communities need, which many of them don't have, are good estimates and projections of vertical land motion in their communities, right? And how those things might change in the future and how that's going to contribute to sea level rise. If anything, they need that as much, if not more, than, you know, slightly better projections of global mean sea level rise. So translating our knowledge across disciplines by working on maybe problems that are outside of your comfort zone, but then also enlisting collaborators and other people within the scientific community who are experts in those areas to work together on those problems together with communities, right? Partly what the issue is here is that communities need us as scientific advocates to marshal the resources and the knowledge within our own scientific community to help them with their problems. If you are a wealthy community, right, who has the resources and to, you know, get your local university to work on these problems, or to get your local government to put money into dealing or researching these problems, then, you know, this isn't a problem for you. But the communities that don't have those resources, don't have those connections, they need advocates within the scientific community to help marshal those resources to help get better information on these other problems. And so here's another example of just very high resolution coastal ocean modeling done here at Georgia Tech by a former PhD student, Kingman Park, looking at how well, so this is basically a 10-meter resolution model of flooding along the whole Georgia coast, and it was validated against this dense network of sea level sensors. But this was really useful for the community because it allowed them to do forecasting in the same way that you would do weather forecasting 1 or 2 weeks in advance, so that, you know, local emergency management officials could prepare for flooding that might be coming, you know, within the next few weeks or a few days, and put forward the resources to help people protect their homes and these sorts of things. So, you know, someone who does ocean modeling, you know, or oceanography for ice sheets can easily apply their knowledge to working on this problem, you know, in coastal communities, you know, their local coastal communities. Okay, and then, yeah, finally, this is sort of kind of what I was just saying, but building these interdisciplinary teams, right? So that means bringing together people who work on different kinds of problems, putting them together with the communities that you've already built relationships with, that you've already laid the groundwork with, in order to solve a range of problems that communities are having that don't just extend to coastal flooding. I think it's easy to say, like, well, we're glaciologists, so our only job is to work on glaciology. And I'm not telling anyone, if all you want to work on is glaciology, that's great. And, you know, I'm not telling anyone that that's a bad way to have their career. But if you want to work with communities, oftentimes communities want, you know, information from science that is not what you work on. And so here's just an example, again, from the Smart Sea Level Sensor project, where they develop these water level sensors. And once they develop the water level sensors, through additional conversations with the community groups that they were working with, they found out, well, some neighborhoods in Savannah, which are not right on the water, right, but which are some of the, you know, most vulnerable communities in these areas, they don't have a problem with sort of flooding from inundation from the ocean, but they have problem due to, or they have problems having to do with rainfall induced flooding, right? And so adding rain gauges to these sea level sensors that were also cheap, that would also connect to the infrastructure that had already been developed for these sea level sensors, was a really easy way for them to expand the usefulness of this project. And then after that, what they found was that other communities who don't have flooding problems, what they do have problems with and what they're worried about is air pollution and air quality in their communities. So again, to the sensor package that already existed, they added these purple air sensors, which any of you who are in the Northeast who have been checking, you know, air quality sensors or information on the internet, right, over the last 24, 48 hours, right, like these are kind of the standard sensor for doing this sort of thing. And that could also easily be added to this sea level sensor package to give communities better information about air quality in their area, and also provide them ammunition for going to the regional EPA office and saying, we have this problem, here's the data to back it up. We need to make some changes in order to, mitigate this issue. So sometimes working with communities means not doing glaciology, but rather, using your team building skills in order to work on a range of problems that communities are having that aren't just related to coastal flooding. Okay, so my takeaways here are really just listing the 6 recommendations that I just talked about, so I'm not going to rehash them, but I'm really happy to continue the conversation over the rest of this call, and if anyone has any questions, I'd be happy to take them. So thank you very much.
Thank you, Alex. That was excellent. Covered a much broader range of issues than I expected, but all quite important and interdisciplinary as well. Thank you for that. Does anyone have any quick points of clarification or questions for Alex before we move on to Nadia? All right. Actually, I have a very quick one out for you, Alex. Before you started engaging with Georgia coastal communities, how many sea level projections were they using? If there was sort of one consensus number.
So prior to about 4 years ago, planners in coastal Georgia were not allowed to use sea level projections to make planning decisions, and that has changed, not by law, simply by different people being hired into certain positions of power, who basically decide what information is used in doing regional planning. And so actually, I mentioned briefly before, I co-teach this class with a civil engineer at Georgia Tech called Sea Level Rise and Coastal Engineering. It's cross-listed across civil engineering students and earth science undergraduate students here at Georgia Tech. And so we teach students sea level science, and we teach them some basics of coastal engineering and then how to use sea level information in coastal engineering. But the last third of that class every year that we teach it is we have practitioners come and give talks to the class. And so we've had one of the main regional planners for Chatham County, which covers Savannah, come and talk to us about it. And we had her talk about it right after she had started her job and kind of what the previous regime allowed and didn't allow. And then we got to hear from her a few years later. And it's really amazing to hear how quickly things can change with the right leadership, right, and the right sort of scientific input. And so I think that's, especially here in the Southeast, where there is a strong intersection between sort of political realities and how climate information is used in communities in general. Scientists have a very important role to play, in ensuring that the best evidence is used in order to make smart decisions, right? Sometimes that means you have to be frustrated, but with sort of political realities. But I would say the best thing you can do is sort of persevere and continue to build those relationships and hope that over time you kind of make inroads, to make sure that better information is being used.
Okay, great. Well, thank you, Alex. That was very much appreciated. So next we'll move on to, we'll stay in the Southeast and move on to Nadia. Nadia, would you like to share your screen?
I would. Give me 1 second. Well, hi, everyone. Thank you so much for inviting me to speak today. I'm really excited to share some of the work that I've done as a graduate student, actually. So I am at Columbia right now as a postdoc, but this work focuses, what I'm going to be presenting, focuses on some of the work that I did in Miami as a graduate student. And Alex, fantastic talk. I think you set up a lot of really wonderful themes that we're going to explore, I guess, in practice in this chat. Can everyone see everything? Is it all good? Perfect. Great. All right. So let's get started. So before we sort of dig into the sort of meat of this research, what I want to say is that the work that I'm going to be presenting is actually more of the second part of my dissertation. It's more the community engagement, the understanding stakeholder perspective component. When I was in, I've lived on and off in Miami for about 10 years, and seeing the impacts of sea level rise manifest through that time was interesting, to say the least. But I think what really resonated with me is how would people be sort of moving in response to these impacts. And so I want to introduce first the concept of climate mobility. And this is a little bit different from, not too different though, from climate migration. It sort of arises out of the idea that climate migration patterns in response to any sort of climate related hazard or climate related risk, they're really difficult to predict and quantify. And for the most part, when I started this work, and I would say even still today, a lot of the studies that have actually been generated on this topic really try to model these macro migration processes. But these types of studies really obscure the decision-making process. They obscure sort of what is happening on the ground and how are people reacting to it. So some scholars are trying to, I guess, sort of, usher in a shift to thinking about climate-related mobility, which is, the ways in which climate reshapes existing decisions to move. I mean, if you think about any major, move that you've made in your life, I'm assuming that climate probably wasn't the driver there. Maybe nowadays it might be a consideration for you, but for the most part, it's not the only sort of push factor. And that's what this work tries to get at. So the work is really focused in Miami-Dade County. As Alex sort of mentioned, the Southeast is a huge hotspot in terms of exposure to sea level rise related impacts, Miami being one of those areas of great exposure. It's also just a highly economically unequal landscape. Lots of the sort of spatial distribution of residents that we see today actually reflect Jim Crow era sort of segregation, and that really has large implications on how people are exposed to the impacts of sea level rise through time. It's also a huge place of refuge for so many different people from Central and South America and the Caribbean as well. And all of those things really do have a role in kind of in understanding how people might sort of react or move or want to move in response to sea level rise. But the interesting thing for me is that Miami-Dade is very active in the space of planning for these impacts. They have to be. But both city plans, county plans, neither of those plans mention the words retreat, displacement, or migration in relation to climate change, which I thought was a pretty big oversight. Oops, went backwards. Because, as I mentioned, the impacts of sea level rise are very visible in Miami. These are two headlines that that I have screenshots from that I show all the time, but these were the types of questions that the city and the county were grappling at when I really started this work. How are people being sort of directly impacted by sea level rise and related flooding? Are they going to take buyouts? Is the city going to improve infrastructure? And then there are the sort of secondary or indirect impacts of sea level rise as people sort of internalize and recognize the risks of sea level rise. They might move to safer areas, but what about the residents who are already living there? This sort of gets at this idea of climate-related gentrification. So sort of recognizing all of these dynamics that were playing out in this very tiny county, on the tip of the Florida Peninsula, I wanted to kind of make sense of all of these dynamics, or try to get a way to think about this, because I actually did attend lots of community meetings in 2019, and it's really great that I had the opportunity to do that before the pandemic hit, because that really did sort of change up a lot of the methodologies that I employed, and I can talk a little bit about that as well. But community groups are really grappling with this, with these questions, and they had all sorts of ideas about how to, or what kinds of questions they like answers to, but, and maybe, referring to something that Alex mentioned in his talk, I can also talk a little bit about how I try to bridge the gap between what communities were sort of requesting and what we could actually reasonably sort of produce. So the first step was really trying to find a way to think about this. And so I developed what I call this sort of climate mobility framework. And essentially what it is essentially trying to capture is that depending on your exposure to sea level rise through time, these sort of direct impacts of sort of flooding, and your level of sort of, I would say social vulnerability, but you could also say sort of capacity for adapting in your own sort of individual way, or I guess without assistance. The intersection of those two things might actually provide us with a really good look at how at potential outcomes for people. And so these sort of outcomes were sort of captured in these 4 categories that I have here. And this is the first part of the dissertation, but they're a little bit critical to understanding why I did the rest of the work. So the first idea here is that there are some communities that are just more stable through time, that these are the communities who are not heavily impacted by sea level rise or flooding, and they have greater capacity and flexibility to sort of mitigate impacts on their own. And so they're just sort of relatively stable through time. Then we have these communities that are more likely to migrate. They are actually exposed to the direct impacts of flooding, but they have their own sort of individual capacity to move, or they can, recognize, they can actually they have options essentially. And there's a lot of literature in that, and I can unpack that later as well. Then we have these communities that are that I call displaced communities. And these are the communities that are not directly impacted by flooding, but are indirectly impacted by sea level rise as people start to move to the areas that they currently live. And if there are no sort of policies in place, that's it's quite an economic force for them to reckon with, and they could be displaced by that as well. And then we have this sort of trap category. These are people who are directly impacted by sea level rise or flooding related impacts, and also have sort of lower flexibility and capacity for sort of mitigating risk on their own. So this was the sort of organizing concept for this dissertation, and we did actually map out how this sort of plays out in Miami-Dade, and I can talk more about that, but I wanted to talk more about what we did to try to validate some of this, try to figure out how were people actually experiencing this, and whether these outcomes, these categories made any sense at all. So the research questions that motivated this work were, what types of flooding impacts are residents experiencing now? How are they coping? What tipping points did participants identify as being critical to staying in Miami or leaving Miami? And how do participants' lived experiences align with sort of the climate mobility framework, especially if they are deciding to move or not? So the first thing that we did was a set of long form interviews. I conducted about 40 interviews with residents across the county. This is when I needed to shift my methods a little bit because this is during the pandemic. And so we did online interviews. We got a lot of different community organizations and governments involved in trying to send out a request for these interviews. And we were able to get 40 people from all across Miami-Dade to participate. And so that was really great. I'll show that distribution in a second. But then we used the information from those interviews to also develop an online survey to kind of get a more robust look at mobility and flooding impacts across the county. And one thing that we did, again, this was more of a needing to kind of adapt under different pressures. This is not the way I would have done this if we didn't have some COVID related restrictions. We integrated high resolution flooding maps into our survey, and we asked people to sort of locate their residents within these sort of zones, kind of zoom in and indicate what flood depth based on our models they would be experiencing under these different sea level rise conditions. And just to take a moment to kind of describe the modeling here, this was done through a partnership with UC Irvine. Their paper was out in Nature Sustainability a few months ago. They used this sort of PRIMO model. They did it first for the greater Los Angeles area, And it's a fast response, high resolution model producing flood exposure data at 1.5 meter resolution. So street level data, really, really useful. And then they repeated that same process in Miami. And so this is just a map of what it kind of looked like in Miami. I can definitely take more questions about that as well, but I would highly, if you're interested, I'd highly recommend talking to the authors of the study. So getting back to the survey, we integrated those maps into the survey and we asked people to kind of, again, indicate what is the level of flood depth that they would be experiencing, because then we also asked them, based on that, would you choose to take no action? Would you adapt in place, or would you move away? And so that was sort of the experiment that we did. And we did this for 0 to 2 meters of sea level rise for just sort of a permanent inundation scenario, and in response to 100-year floods as well, which we call extreme flooding here. So getting back to our respondents, so map A shows just a distribution of the home addresses of the participants across Miami-Dade. I was pretty happy with that because it was not only sort of coastal residents, but residents north, south, and inland as well. Map B shows more of the distribution of our survey, so we tried to get really good coverage across the entire county. I would say just very quickly that our respondents are actually not very transient, not part of the transient population of Miami. The median years lived in both our survey and interview was around 21, 22 years. And most people for both the survey and the interview we're making around or under the household median income for Miami-Dade of around 52 to 54,000. So getting to question 1, and this is for our interviews only, and it gets to what Alex also mentioned for Georgia. The most reported flooding impact for the past 5 years, and in this case, I think we asked them about 2016 to 2021, was rain-related flooding. That is what most people had reported experiencing. And that was also very much reflected in our surveys as well. So we had about 75% of people indicating that they had experienced some kind of flooding impact from rain in the interviews, and about 70% in the surveys. I'm sorry, I should have mentioned that we had about 600 people answering the surveys. I didn't mention that. 40 people within the interviews and about 600 in the survey. Some of the major impacts that people have reported experiencing were major damage to their vehicle, engine damage. And something that I thought was really interesting that we observed in the survey was that about 1/3 of participants reported an inability to commute to work or school from this flooding. And that was really interesting because in our interviews, we only had one respondent sort of indicate that type of an impact. And he said, kind of describing a compound flooding event. There was a full moon, there was a high tide, and it just rained. I had to park my car somewhere else. I had to call out of work because it didn't drain the next morning. It stayed like that for over 48 hours. And you could see fish going through the streets of Doral Boulevard that had come up from the canals. So this was, one person from the interviews, but about 1/3 of respondents in the surveys said that. So in getting to question 2, trying to figure out, okay, well, how are these experiences contributing to decisions to move in the future or right now in response to climate? We first wanted to ask people, okay, well, are you thinking about moving from Miami right now? And in our interviews, a little bit higher, people, a little less than half of our interviewees said yes, but about 40% in our surveys. The amount of people that said no, about 35, 38% was pretty stable across the interviews in the survey. When we asked people what were the main reasons for that, affordability, about 72% said that. But again, this is without prompting for any kind of climate-related hazard. Flooding and increased heat also came up as well in these instances. So climate is clearly having at least some impact here. Getting back to our experiment that I mentioned earlier, you can see the breakdown of how people said that they would respond to either our sort of extreme flooding scenarios from 0 to 2 meters of sea level rise, or just the sort of inundation responses here. So what you'll notice is that in the blue, there are most people preferred to adapt across in all of these scenarios. In the extreme flooding scenario, you'll see that that's sort of higher here. And then in the inundation, taking no action is a little bit higher, but that's because there just wasn't as much flooding that was being experienced there. So that was pretty consistent. And the preference for moving sort of marginally increases as sea level rise increases, and the preference for adapting sort of marginally declines as sea level rise increases in that sort of extreme flooding scenario. And that is very much in line with what we thought. We didn't think that people would just sort of say, yeah, I can't wait, you know, I'm ready to move just based off of this flood map. So we wanted to take a look at what are the drivers of some of that decision making. And here, some of the things that really stuck out, we did some chi-square analyses. If you were over the age of 65, you were more likely to express that you would take no action. If you also were not concerned with sea level rise as well, you're more likely to say that you would take no action. If you thought sea level rise was a current risk, more likely to be associated with a decision to move. And then I think interestingly enough, you know, your confidence in the ability to prepare for flooding was also a very strong driver for those people who did not feel confident at all. They were more associated with a decision to move. I know I'm running out of time, so I'll just try to get through this really quickly. In terms of whether or not people aligned with the framework, I would say that there was very decently close alignment for those people that were categorized in this sort of stable category. They mentioned wanting to live on the highest points of elevation in Miami. And for those people who were aware of sort of flooding in their who were categorized in this sort of migrating category, they were aware that they might need to move because the values of their homes might drop. So they cited a financial sort of reason for doing that. The displaced category was a little bit interesting in that we didn't really find sort of gentrification related impacts. We did find that people mentioned if the flooding was excessive, they might consider moving because that would be the only solution. And that was echoed in the trapped category as well. You know, if it's really that bad, it's going to cost more to fix the house than handle flooding, they would have to consider moving as well. I'm going to skip past this and get to main takeaways. So main takeaways are sea level rise is very much reshaping mobility decisions, and I expect that they will continue to do so. And this model of thinking about mobility in this way, as opposed to some sort of mass movement or mass exodus out of a region, I think is just more consistent with the way that people are sort of integrating climate risk today and responding to it. Most residents prefer to adapt in place, but that might not be sufficient under high sea level rise scenarios. Rainfall related flooding is a driver of mobility now. It's very understudied, and to some extent it's not clear whether it's being incorporated into adaptation planning. The water management system in in South Florida is taking this into account, but other plans not really so much at this point. And this idea of being trapped is really layered. It can, you know, it can be a result of many different things, including affordable housing, excessive damage to homes, and, you know, being caught in the cycle of sort of asset and municipal devaluation. So I knew I threw a lot of information at you right now, but I'd be I'll acknowledge my collaborators and my funders, but also I'd be happy to take your questions as well.
Awesome. Thank you, Nadia. That was really great. I learned quite a lot there. I really appreciate that. We're almost at the top of the hour, but I'm hoping folks can stay for questions for Nadia and Alex. Any questions from the audience first? I know I've got a couple. Nadia, one of your takeaways there about the rainfall related flooding was really humbling. That was not something that I'd really, well, you know, kind of connecting back to Alex, thought much about as a glaciologist, but you know, if that's one of the main potential drivers for people to mobilize as a result of climate change, that's really important to know.
Yeah, you know, it was shocking to me as well, and it really shouldn't have been, because I have literally driven through rivers of water in Miami after rainfall events, and until I saw it reflected in my own data, I probably never thought too much about it either.
Yeah. am I correct in recalling, so the median for your interviewees, the median was half of them, median residence time was 20 years, but
2020, 21, 22, yeah. Mhm.
but in the survey, half of the folks were thinking of moving, partly as a climate relation, but also affordability.
Yes, yes.
Wow.
And I should also mention that these surveys took place, I would say, 2020, late 2021. So
Okay.
I think at that point, people were also, experiencing pandemic-related affordability issues as well.
Yeah, absolutely. Ken, you've got a question.
Yeah. Hi, I have a question for Nadia. I apologize if I missed this, but what was the mean elevation of the respondents? Because I was surprised that for the 2-meter inundation, like and that's not a flood event, that's just like a permanent rise, right? That it was a 20% will move. And so I'm wondering if people like understand the magnitude of a 2-meter inundation and just saying, no, I'll adapt or nothing. Like, yeah,
great question. I can't recall at the top of my head, but what I will say, just to speak to that, I guess that observation, in one sense, I'm not shocked because I can't imagine that people will look at these flood maps, and so a few different things, that they would look at these flood maps and then say, okay, well, I guess I'm going to move now. But at the same time, I would also, this was not the way that I had ever intended to do this work. It really kind of, arose out of a necessity, more or less. I would have preferred to kind of do focus groups and kind of walk through this modeling with people. And kind of explain sort of the implications. It was not ideal to kind of do this within a survey. And so I would also probably say there's just a chance that maybe most people didn't understand the models very well, but I also think that maybe people, what we show them, the information that we show them isn't enough to convince them to move. Maybe they're not sure how much of a reality it is. 2 meters is quite far out for Miami anyways, so maybe there just wasn't kind of clicking.
Is there I haven't been to Miami myself personally, but are there water lines that are obvious when you're along a boardwalk or a building or something like that, where you you see how high things have flooded already and might in the future? I mean, I see examples of daytime flooding associated with tides, not so often with rainstorms, although I guess they do occur. But are there these strong visual indicators of what can happen relatively easily in places like that?
That's a great question. I don't know if there are markers per se, but I mean, I think something that this work really highlighted for me is just sort of the shift a bit in perspective that residents are maybe kind of because it wasn't just coastal residents who were saying these things. It was residents who were living inland as well, and they are recognizing that they're being, sort of flooded just by these rainfall related events. And so it was sort of, I think there, and this is something that if you have a look at social media on any day in the wet season in Miami, people will post things about, how much flooding is ongoing. So I think it's fairly visible. The 70% number of just people reporting sort of rainfall related. I think that there is a bit of a shift. I don't know, Alex, I'd love to get your perspective as a Miami native, if you've seen that change or your family expresses that.
I mean, the thing that from your survey that really spoke to me and was not surprising to me was that the largest fraction of residents who are thinking of moving are thinking of doing so due to affordability reasons, right? And I think that whether people explicitly know it or not, they are responding to changes or stressors that are related to these things. And so Nadia, was actually going to ask you a question about like disentangling this sort of affordability concern from sea level rise and flooding, because flood insurance in Florida has increased a lot on average, and Miami even faster due to the insolvency of a lot of state level insurance companies, and Citizens, which is the insurer of last resort in Florida, has increased their premiums by a lot. And so like someone might see their home insurance going up, or even just their rent going up, right? Which if you're a renter, you don't see the insurance number, but you see that your rent goes up, and that says to you like, well, it's no longer, in fact, and that people in my family have left not just Miami, but the country, because it's no longer affordable for them to rent there. And you just see that as like, well, there's all these people moving here, and that's why it's expensive, but behind a lot of that can be things that are related to the increased frequency of damaging flooding, which has changed insurance rates and all of that. So I think that like perceptions are changing, but they're not necessarily changing directly related to sea level rise. I mean, I think that those have shifted a bit as well in the last 20 years. I mean, I haven't lived in Miami in 15 years, so I haven't been a resident for a while. But yeah, I think especially in a place where the sort of political environment around these things is a bit fraught. There may be many people who don't want to think that they're responding to this sort of very obvious impact of climate change, so they name something else, like affordability, and they might be leaving because of affordability, but they don't necessarily make that connection to these other things. So I think it's complicated, I guess, is the answer, right?
Yeah, absolutely. I mean, in the interviews, I did have people kind of try to disentangle this a little bit. Like I'm thinking of a homeowner from Palmetto Bay who said that he's just moving after like he retires because he doesn't want to deal with the flood insurance anymore, and he's required to because he is living in a floodplain. But yeah, I think it's very hard to disentangle these dynamics. I actually did have a question for you, Alex, based on something that I think it was the first study that you presented, because it harkens back to something in Miami-Dade. So something that I didn't present is that Miami has really wonderful unified sea level rise projections that 4 counties in South Florida use, and they have different scenarios. But Miami-Dade County opted to go with 2 feet of sea level rise as they're planning their one sort of number until I think 2060. And so I wondered also if the study, or in your experience, do you find that maybe people are perhaps not using the correct or the most or the best available science, not because they don't have access to it, but because largely in part some political reason or some other reason that is not known to the scientists who are working with them?
Yeah, I mean, I think that like there are many examples of that sort of thing, and I actually thought it was curious, right, with the numbers that I showed from the Hirschfeld study, that like on average the numbers that were being used were actually above the consensus 2100 global mean sea level projections. Now, that being said, we're already looking at a subsample, right? Because that was only looking at people who used any sea level information, right? And so I was just showing, but if you look at the broader survey, like there is a sub part of the population which is using no sea level information in planning. So in some sense, like the implicit information that is being used there is that sea level rise is going to be 0, right? So if you included that in the numbers, that might bring things down a lot. And in fact, when you look outside of North America, the numbers using only one number or not using sea level information is a much larger fraction of the sort of practitioner population. So I think there's that. And I do think, like, I mean, at the end of the day, it has to do with governance structures and how decisions are made. There's sort of the capacity for, incorporating unelected let's say, unelected people who may be more insulated from, let's say, the decisions or from the possible repercussions of planning based on more accurate information, right? That if you are a local politician and you say that we're going to use this level of sea level rise information in planning, and as a result of that, our taxes are going to be higher, right? Because we have to build all city infrastructure, this much higher, or that's going to cause insurance premiums to go up because insurance companies are going to use that as a signal to say like, this is a risky place to build. I mean, it could also go the opposite way, which is that you're making good decisions, so insurance companies think they're less likely to pay out. But basically, it's if politicians think that they're going to be punished for incorporating this information in decision making, then that incentivizes them, to not use the information or to use lower numbers or things like that. The interesting thing, and this will just be a quick anecdote, which is that in California, there was a big fight over this a few years ago where this was around 2016, 2017. This was a time in the sea level projection community when the sort of high end of sea level projections had jumped up because of, honestly, one study. And this sort of high end sea level projection was used as the basis for setting the statewide standard for planning in California. So the planning level in California is closer to 2 meters now for 2100, right? And if you talk to practitioners now, there's some practitioners in California, there's a lot of regret over that because a lot of communities are just choosing to ignore that because it's way too high of a target. It's way too expensive for them to build to that standard. Right. And so, it kind of happens on both ends, I would say, probably more frequently on the low end, like you were talking about. But, when people are responding to incentives that are not directly related to the scientific information, then, it makes it more likely, I think, that they're going to, use numbers that are not necessarily in alignment with, the community, the scientific consensus.
Great. Yeah, agreed. Great. Any last questions for Nadia and Alex? Okay, great. Then I think we'll stop it there. A lot to chew on for sure. I'll be referring to some of this thinking, I'm sure, down the road. And I'm sure others will as well. So thank you so much, Nadia and Alex, for taking the time, and for everyone for joining. And yeah, we will see you again soon with the Glaciers and Sea Level Community of Practice. And yeah, this might be one I'll be watching again. Thank you guys. Really appreciate it.
Thank you.
Be well. Bye.